Okay, I want to start off today's video by going over problem number 55 from tonight's homework set, Q1, day 9. So on problem 55, you guys need to apply these properties that we went over in the last video. Okay, and the way we're going to apply them is, so right here I just kind of have a copy of the property that we're going to use. The first sum or difference rule, because we happen to be adding. But they're telling us to assume that the limit of f of x as x approaches 4 is 0, and the limit of g of x as x approaches 4 is 3. So the limit of g of x plus 3 as x approaches 4, what is that? So this is how we're going to apply them. So we have, according to the property, we get this. Okay? Now this produces 3 plus. Now notice, this was a little tricky. Notice that the limit of 3 as x approaches 4, the function is just 3. There is no variable x. So the limit as x approaches 4 is not affecting this function. Therefore, we just keep it 3. So 3 plus 3 is 6. Okay? Okay, so part B, again, I'm going to go ahead and give you guys the example of the property we're using. We're assuming the same thing. Now the limit as of x times f of x as x approaches 4, the way we're going to apply that is, think of it this way. Okay, so this is direct substitution. Once again, I also went over this in the last video. Whoops. So if we directly substitute, we get 4 times, now this part right here, we're going to get 0. So in reality, it didn't matter what this produced because this is going to be 0 and anything times 0 is just 0. Okay. Hopefully that little help will help you finish 55C and 55D. Okay. What we're going to do is we're going to work on, before this one, let's do this. Let's add to your 2.1 notes from page 66, problem number 25. The directions say explore the limit graphically, confirm algebraically. Okay, so remember, pauses at any time so you can copy this down into your notes. Okay, and this is the graph that we get from this given function. Oops. Okay, one thing I want you guys to notice is that at x equals -1, we have a vertical asymptote. Okay, so this graph, from the right side, it goes to positive infinity at -1, and from the left side, it goes to negative infinity, okay, at -1, which makes sense because looking at the domain, x cannot be plus or minus 1. Okay, so the question was, so we have to have an open circle there, but the question was, what is the limit as x approaches 1? So like we went over in class today, we have to first check the limit as x approaches 1 from the negative side of this function. Okay, so we're getting very, very close, very, very close to what appears to be 1/2. Okay, the output value of 1/2. And we got to compare that to the limit from the right. Okay, again, we get very, very, very close, and we're approaching the exact same value of 1/2. So the answer should be 1/2. Now, how are we going to do this algebraically? Okay, so to do this algebraically, we have to do direct substitution. Okay, so there's a problem here. When we directly substitute the 1, we get 0 over 0. Okay, this is called indeterminate form. When we get indeterminate form, that means we can do some kind of algebra, some kind of simplifying. We can simplify this function so that we can go ahead and reapply direct substitution and get an answer. So hopefully you guys can see that we can factor the denominator. To that, we get this. So now we're going to apply direct substitution to 1 over x plus 1. So the limit of 1 over x plus 1 as x approaches 1 is 1 over 1 plus 1, which is the 1/2 that we saw graphically. Okay, so now number 26 from that exact same page. Once again, explore the limit graphically, confirm algebraically. So if we look at the graph, there it is, t squared minus 3t. Now remember, once again, we get this vertical asymptote at -2, which makes sense because of our domain. T in this case cannot be plus or minus 2. So that means at +2, we should have an open circle. Okay, so the limit of this function t squared minus 3t plus 2 over t squared minus 4 as t approaches +2 from the positive side. So as we get, let's do the negative side here. Let's start with the negative side. Okay, so as we get very, very, very close to t is equal to 2, it seems like we're at about 1/4. Okay, we got to compare it with the limit of t squared minus 3t plus 2 over t squared minus 4 as t approaches 2 from the positive side. So hopefully you guys are getting more and more familiar with the limits graphically, and you can see that we will be approaching the exact same value of 1/4. Okay. Now, however, when we want to start looking at this algebraically, we want to confirm this algebraically, we get, once again, direct substitution, 2 squared minus 3 times 2 plus 2 over 2 squared minus 4. Okay, that's 4 minus 6, negative 2 plus 2, which is 0 over 0. Once again, we call this indeterminate form. That means we can do some kind of algebra to simplify this. Okay, by where I would pause this, try to see if you can apply the simplifying ways, or try to figure this out on your own. Then press play and check your answer. But if we factor the top, we get 2, we get 1 minus minus, whoops, the bottom, let's factor that, t plus 2, t minus 2, they'll simplify. So now we're going to get this, which is 2 minus 1 over 2 plus 2, which is 1/4. Okay? Hopefully you guys caught on that in both of these problems we got 0 over 0. That's not the problem. And this one we also got 0 over 0 when we applied direct substitution at first. Okay, here's a little note that I want you guys to add for when you get 0 over 0. If direct substitution produces 0 over 0, we call this indeterminate form, which means we can simplify the function and reapply direct substitution. Okay? And that is it for today.